right, Algebra. We're going to do a quick trig, another trig lesson. Lesson 11-6, angles of elevation and angles of depression. And basically what these are trig story problems. Okay, no, don't panic. I know what you're probably thinking. Oh no, here comes the half a page long problems. No, trig story problems are a little bit easier, a little bit simpler, and I don't require as much. And I'll go over a few examples on what I want the trig story problems to look like. So, angles of elevation and depression. So if my theta is down here, and I am just standing there. So let's say a person is just standing there looking up. So let's say there's this little person here, boom, 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 cute little guy, just standing there looking up. That is an angle of elevation. Okay, let's say you are in a plane. I'm not going to draw a plane, obviously. That does not turn out very well. But let's say you're flying in a plane and you're looking down. That's an angle of depression. Okay, these two angles are congruent. Okay, they are congruent angles, which means whenever I'm given a trig story problem and they tell me the angle of depression or the angle of elevation, I am always going to stick my theta or my angle measure in that bottom corner. Always, always sticking it in that bottom corner. And then I find my trig ratios. Okay, so again, angle of depression, angle of elevation, they are congruent angles because they're what we call them in geometry. They're alternating interior angles. Okay, so when you have those two angles, that means that they are congruent. So these are two congruent angles. So whenever they're talking about the angle of depression, angle of elevation, I am always going to stick that angle right there in that bottom corner. Okay, so what I want for my trig story problems, draw a picture. Your picture is your right triangles. Okay. Set up your trig ratio. So here comes your SOHCAHTOA. Solve. And that's when you're going to cross multiply to solve, get your answer, and then write me a complete sentence. Okay, colleges, anytime you're dealing with those upper division levels, they want things done in complete sentences. Okay, so I'm going to come over here. We're going to look at a trig story problem. It says, suppose the angle of elevation from a rowboat to the top of a lighthouse is 70 degrees. You know that the lighthouse is 70 feet tall. How far from the lighthouse is the rowboat? Okay, so here comes our trig story problem. Okay, so picture. Let's do our right triangle. They said that the angle of elevation, and you can rewind it back and look at the story problem again, the angle of elevation is 70 degrees. So right here in this bottom corner goes that angle. Okay, that goes that angle. The lighthouse is 70 feet tall. Well, if this is my lighthouse, we'll draw a little light here, a little house, looks good. If that's my lighthouse, and it is 70 feet tall, okay, so that's 70 feet. Ignore my, look at my beautiful lighthouse. And they want you to determine how far from the lighthouse is the rowboat. Well, if this is the water down here, your little boat would be over here somewhere. So we are looking for this distance. So we'll just say our boat is here. Again, not drawing a boat. I wouldn't go this way because that is just figuring out what this little, how far it would be like crawling up to the lighthouse. This right here is how far the boat is away from the lighthouse. So let me draw that lighthouse a little bit better here. Draw this little guy a little bit better. So it looks a little more houseier. Okay? And again, it is 70 feet tall. So what are we looking for? That distance down below there from the boat to the lighthouse. So if this is according to this angle, again, here comes that SOHCAHTOA. Okay, so if this over to here is opposite, because it's across from it, this is adjacent because it's right next to it. That's your hypotenuse. Okay, you don't need that. We will not need sine and we will not need cosine. We'll need tangent. So my second step, I'm setting up my trig ratio. Tangent of theta, which was 70 degrees, equals opposite over adjacent. Let's cross multiply. A, because I'm going to multiply this over here, this sticks over 1. A tan 70 equals 70. Well, how do I get A by itself? We're just going to divide by tan 70 again. Make sure your calculator is in degree mode. So that means that x, I shouldn't say A, I should have said x, so you guys don't get, it should have been x. X equals approximately 25. So now I would say the boat is 25 feet from the lighthouse. Okay, the boat is 25 feet from the lighthouse. Okay, so there's that example problem. Let's look at another one. Okay, I'm going to go ahead and erase this one. Let's look at another one. It's one thing I love about these YouTube videos. You can pause and rewind. So, a pilot is flying a plane 15,000 feet above the ground. The pilot begins a 3-degree descent to an airport runway. How far is the airplane from the start of the runway in ground distance? Okay, so I am going to show you this. A pilot is flying a plane 15,000 so you can see it, so that you can pause it and go back to it. So here comes our right triangle. Okay, we've got our airplane up here. AP for airplane. Again, not drawing that plane. I can't draw. So airplane is above the ground 15,000 feet. So this is going to be 15,000 feet, right? Because it's above the ground. Okay, if this is my ground, the airplane has to be up here. Okay, it has a 3-degree descent. Now remember what I said about that angle of depression. These are congruent. So I would place my 3 degrees right there. That's what I'm going to work off of. We want to figure out how far is the airplane from the start of the runway in ground distance. Okay, so how far is the airplane from the start of the runway? Well, if we are descending down, right? So we're making that descent down. I'm hoping that this airplane wouldn't be down here scooting across the ground. It's scooting this way to make it to the runway, if this is the runway. So what we're trying to find now is this hypotenuse. Okay, so that's our x. So this is your h. According to this angle, that is your opposite. Sine is opposite over hypotenuse. So that's why I'm going to use this trig function. So I would write this as sine 3 equals 15,000 over x. Again, this is a proportion, so just stick it over 1. Cross multiply. X sine 3 equals 15,000. Divide by sine 3. X equals 15,000 divided by sine 3. When you plug that into your calculator, your x should equal approximately 290,000 feet. Okay? Should equal 290,000 feet. So then you would state it's about 3. The plane is about 290,000 feet from the runway. okay, which is very important. And let's say you wanted to put that into perspective. Well, how many feet are in a mile? 5,780. So divide that. If you took this divided by the 5,780, you would get approximately 5 miles. So that means that that airplane is only 5 miles away from hitting that runway, which that is so real world. They're using that stuff all of the time. Okay, trig is used all the time to find the heights of buildings, to find obviously the descent. A lot of this is vectors too, so don't get that confused thinking that that's all trig. So a lot of airplane stuff is vectors. But trig is so real world. That's why in a lot of professions out there, you will have to know how to do trig. Okay? And a lot of people think trig is fun. If you guys are still struggling with how to figure out what's opposite, what's adjacent, make sure you let me know when we have our Zoom meeting so that I can sit down and maybe do like a special Zoom session on some of this stuff. Okay, so I'm only going to have you do about 4 story problems. Okay, each story problem for these are 5 points each. Okay, so you'll have 4 of them. 4 times 5, 20 points. So it'll be a 20-point assignment. Make sure you're showing all of your work and make sure you're showing all the steps. And then when you have questions, make sure you're messaging me. Show me what you have. Take a picture of it. Send that to me. Show me what you have. So then I can help you with the placement of where things need to go. Or just let me know where you have things placed. Okay, so that is angles of elevation, trig story problems. They are actually not too bad. So if you have questions, you know how to get a hold of me, guys.